Okay, number 38, they're asking us for the vertical and the horizontal asymptotes. So the first thing is the vertical asymptote. The vertical asymptote is when you have a rational function, which is what we're given here. Basically, you're given something with fractions and polynomials inside of fractions. The vertical asymptote is when the denominator is equal to 0, because when the denominator is equal to 0, it is undefined. So all you have to do is take the vertical asymptote, set it equal to 0, and solve. Add 20. So I'm going to solve x squared minus 25 by adding 25 to both sides. X squared is 25. Take the square root. X equals plus or minus 5. So there's my vertical asymptote. The horizontal asymptote is calculated depending upon what kind of function you have. So I call this bottom heavy because the bottom exponent is bigger than the top one. When this happens, this means the bottom grows faster. So let me write bottom heavy. But when this happens, it means the bottom grows faster than the top. The denominator grows faster than the numerator. So think of a situation where that's the case. So when is it such that the bottom grows faster than the top? Well, this would be like if I was getting 1/2, 1/3, 1/4, 1/5, etc., etc. And if you look at the decimal equivalents, you're going to notice that these numbers are gradually dropping, right? By 1/10, you're at 0.1, etc., etc., right? So what are these numbers dropping towards? Well, you could graph it on a calculator, and you could look at the table and see what the numbers are getting closer and closer to. But it should intuitively be kind of realize that you're getting closer and closer to 0. So what that means is that when your function is bottom heavy, when the largest exponent is on the bottom as opposed to the top, that just means your horizontal asymptote is y equals 0. It means your function at some point, I don't know what's going on in the middle, but the function gravitates towards the x-axis. And that line is y equals 0. Okay? So let's look at the next one. 3x minus 7 divided by 5x plus 12. Again, vertical asymptote. Hopefully you recall from the previous problem, vertical asymptote means the denominator is equal to 0. And solve, so x is going to be negative 12 over 5. Okay, for the horizontal asymptote, let's see what happens here. So what we're actually concerned with is for large values, what happens to x? Well, for large values, you don't really care about negative 7 or 12, right? And you can literally think of it as, if I have $1 billion and I buy myself a $7 cup of coffee, do I really care? No, you don't. Or if I'm a billionaire and someone's like, oh, I want to be your friend, let me give you $12. Do I really care if you give me $12? If I'm a billionaire? Not really. It's not going to affect me in any capacity. So what this means is that I'm actually left with 3 times a big number divided by 5 times a big number. And so the big numbers will divide out for very large values, right? And I will be left with 3 over 5, and that is the horizontal asymptote. So when the exponents are of the same power, you divide the leading coefficients. Okay, so when the highest exponents, which is called the degree, are equivalent, then we divide the leading coefficients. So we divide 3 over 5. So y equals 3 over 5. Okay. Now the last one, again, vertical asymptote. The denominator is set equal to 0. Hopefully at this point that's popping in your head. This one is called top heavy because the exponent on the top is bigger than the exponent on the bottom. When it's top heavy, this function no longer has a horizontal asymptote. Okay, it has what's called a slant asymptote. Okay, so intuitively, the top grows faster than the bottom, so this thing gravitates away towards infinity. But it gravitates along a slant, and that slant is the division of x squared minus 4 divided by x plus 1. Okay? Now, the easiest way of doing this is via synthetic, because synthetic is easier. But notice you don't have an x term right here. So what we end up getting is 1, 0, negative 4. In other words, I'm rewriting this as x squared plus 0x minus 4. Right here, this plus 1 is going to become minus 1, and we apply synthetic. So that means we drop the 1, multiply negative 1 by 1, you get negative 1, add it, you get negative 1, multiply negative 1 by negative 1, we get 1, and we get negative 3. This is the remainder, this is the constant, this is the x, so this becomes x minus 1. Note, when we're looking for the slant, we do not care about the remainder. So it's just y equals x minus 1, and that's my slant. So, there you go. Remember when it's top heavy, this is the case where it's top heavy, you have the higher exponent on top. When that is the case, you do not have a horizontal asymptote. Hopefully this makes sense. See you all in the next video.